in behavior is what we call the behavior at the far left and right side of the graphs of polynomials. To determine the end behavior of polynomials, we look at two things. We look at the degree first, and if the degree is even, we can say that both the left and right-hand side, so the left and right end behavior, will be the same. Now, a good example of this is a quadratic. So this is x squared, and it has an even degree too, and both the left and the right hand side of this graph go up. An odd degree polynomial, the left and right end behavior will be different. And a good example of this would be a cubic. So x to the third power the right side, should be a 3. The right side should go up and the left side goes down. So those end behaviors are different. Now the degree only gives us part of it. It tells us, are they going to be the same or are they going to be different? The leading coefficient gives us the other part. And if the leading coefficient is positive, then the right side will rise or go up. And if the leading coefficient is negative, then the right side will fall. So if you combine what you know about degree and what you know about leading coefficient, you can determine the end behavior of polynomials without having to graph them, which is handy. So let's look at these two examples real quick. And first we're going to look at what is the degree. So in this particular example, my highest exponent is 4. So my degree is 4, which is even. And my leading coefficient is -5, which is negative. So the leading coefficient tells me my right side will fall. And because the degree is even, I know both sides will do the same. So the end behavior should fall on both sides. Now this example over here, my degree, my highest exponent is 5. So my degree is 5, which is odd. And my leading coefficient is 6, which is positive. So my positive leading coefficient tells me my right side will rise. And because I have odd degree, I know the left side will be different from the right side. So that is a brief sketch of my end behavior. Once we have determined the end behavior, on the left it does this, on the right it does that, there is a fancy mathematical way to write it. So let's look at a graph real quick, and I don't know, I'm just going to make something up here. So here's a graph of a polynomial. And let's describe the end behavior of this graph. So in English first, I'm going to say on the left, the graph falls. And on the right, the graph rises. So that's the English description of this end behavior. Now let's use mathematical terminology to describe that. And what we're going to say is as x goes towards. So as x goes towards negative infinity, and that means on the left, because here's my x-axis, here's negative infinity, here's positive infinity. So as the graph goes to the left, what is it doing? It's going down, or it's going towards negative infinity. So as x goes towards negative infinity, f of x goes towards negative infinity as well. So this piece means on the left, and this piece means the graph falls. Now let's do the right side. On the right, so as x goes towards positive infinity, f of x does what? Well, here's my graph. F of x goes towards positive infinity as well. So each time you describe end behavior, you're always going to use on the left and on the right. And then whether your graph goes up or down, that's going to change. So you're going to kind of have this like standard format, and it's going to look like this. X goes towards negative infinity. F of x goes towards, and this is where you're going to fill in the blank. And here, x goes towards positive infinity. F of x goes towards, and here you're going to fill in the blank. So remember what this means. This means on the left, and this means on the right. And over here, you are either going to put in infinity or negative infinity, depending on if the graph rises. So this would give us a rise, and this would give us a fall in our graph. Hopefully that makes sense.